Okay, so we're back again talking about transformations of parent functions called Offspring graphs. This is the same notes you took last time, so just kind of get those notes back out, refresh your memory about A tells you concavity, H, which is inside, lies to you, so it tells you the wrong direction, but K on the outside will tell you the right direction because K doesn't lie to you. We did an absolute value graph last time, so we're going to do a different example this time. We're going to walk through this blue example, which is a quadratic, because it's got the squaring on the outside. So we're going to figure out what's happening to this quadratic function. Well, again, in this video, I'm not going to change the a value on you. We're still going to have a concave up function because this number in front of your parenthesis, which I understood 1 there. So your a value is a positive 1, therefore you have a concave up graph. I'll change that for you on the next video. Right now, let's just talk about the vertex. So we're trying to figure out this new vertex. We want to figure out what we do with our parent function. So the vertex of our offspring takes the parent vertex, which is usually at 0, 0, and this tells us to move left or right and then up or down. So remember, there's 1 on the inside. That's your h value. That 1's lying to you. So it says positive 1, but what that really means is your vertex now is a negative 1. The k value on the outside, however, doesn't lie to you. This one tells you the truth, so your k value of your vertex really means a positive 4. So your new vertex for this quadratic is a negative 1, positive 4. So there's my new vertex location. Okay, and so negative 1, negative 4, that vertex, sorry, negative 1, positive 4, there's my new vertex. I want to plug in numbers around negative 1 so I can figure out the actual shape of my quadratic graph, which we know is going to be a U, but we need to know exactly where the points are. So around negative 1, well, that would be negative 2 and negative 3, or 0 and 1. So I'm going to slide this over so we can show some work here. And we're going to plug in these points, and I'm going to make it a little bit bigger so we can see. We're going to plug in these x values, and we're going to figure out what these new y values are going to be. So here we go. So if I plug in my negative 3, I'm going to take my function. In place of x, I plug in negative 3, and then I follow PEMDAS. PEMDAS says to do inside parentheses first. So negative 3 plus 1, well, that's a negative 2. Then PEMDAS says to square. Negative 2 squared, watch your signs. Negative times a negative is a positive, so I should get a positive 4. And then I can add or subtract. So in this case, 4 plus 4 would give me an 8. So my new order pair, or my next order pair, will be negative 3, positive 8. Do the exact same thing with the negative 2. I'll change my colors again so you can kind of see where my work stops and starts. Plugging in negative 2 plus 1, quantity squared, plus 4. Parentheses first. Negative 2 plus 1, well, that's a negative 1. Negative 1 squared. Negative 1 times negative 1 is positive 1. And 1 plus 4 is 5. So my new order pair, or my next order pair, negative 2, 5. I'm going to jump down below my negative 1. I'm going to plug in 0. Same thing, replacing that x with a 0 and doing some simple math. 0 plus 1 is 1. 1 squared is 1. 1 plus 4 is 5. So I get 0, 5. Plugging in 1. 1 plus 1 is going to be 2. 2 squared is 4. 4 plus 4, I get 8. And you'll notice the symmetry in your ordered pairs. You'll notice your symmetry in the y values of your ordered pairs. So if I slide over here to plot that function, to plot these ordered pairs, I'll plot these points on this side. I want to plot the point negative 3, 8. And I'm pretty sure I don't have a lot of room, but I'll make it fit. Negative 3, 8. So 1, 2, 3. So my negative 3. And then 2, 4, 6, 8 puts me right here. Negative 2, 5. So negative 2, 2, 4, 5 puts me here. I've already got my negative 1, 4. I want my 0, 5. So 0, 5 puts me here. And my 1, 8 puts me here. Being very careful to recognize this is a quadratic, a squaring function. So when I connect these, I need to connect these to be very, very round. So I want to hit my dots. Don't want a V graph, I want a very round graph. Looks like that. Okay. So we'll slide down. We'll do another one. This next graph is going to be our cubic function. You see our little 3 up here. So it's going to be the cubic graph. And we're going to have to figure out our new vertex. And I didn't draw my coordinate planes. Let me draw that real quick here. Alright, so my new vertex, again the A value is 1, so it's going to be concave up, going to be a positive. But my new vertex, inside lies, so my H value says -2, but it's really going to be a positive 2. Outside tells the truth, so positive 2, -1. That's my vertex, or my middle point of my cubic function. A cubic function doesn't really have a vertex, but it does have that middle point. So again, here's my cubic function. This is the point we're referring to right here, this middle point. Okay, this point of inflection is what it's actually called. So, 2, -1. To show my work over here, here's my order pair. Points around 2, we'll go back to 1 and 0, and then 3 and 4. And again, we're going to plug in, using order of operations, we'll get out some y values. So plugging in a 0. Inside parentheses first, 0 minus 2, well that's -2. -2 cubed, be very careful, that means -2 times -2 times -2. So you should get 8, but it's going to be a -8. And -8 minus 1, well that's a -9. Plugging in a 1, 1 minus 2, is going to be a -1. -1 cubed is going to be -1 times -1 times -1, which is a -1. Then minus 1 from that is going to be a -2. Okay. Doing my 3. 3 minus 2. Well, that's a 1. 1 cubed. 1 times 1 times 1, which is 1. Minus a 0 is going to give me a 0. Take care of my 4. 4 minus 2, well that's 2. 2 cubed, 2 times 2 times 2, well that's going to be a positive 8 this time. Minus 1 is going to give me a 7. So I've got some big points to plot. I'll slide back over here to where we can kind of see my graph, and we will try to plot these points. So we've got 4, 7. So here we go. Here's 4, and 2, 4, 6, 7 puts me here. I've got 3, 0, 1, -2, and then the one I probably don't have room for is 0, -9, but here we go. Here's 0, 2, 4, 6, 8, 9 puts me way down here. So my graph would look like that. Okay? And then I am going to flip it over, this paper over, and we're going to try one more at least for this one. This is the one that a lot of kids find very hard to do because it's a square root problem. And we just kind of have to be careful about what points we use. So again, the vertex, looking on the inside, you get a positive 2. That means my vertex is going to be a negative number, a -2. Outside's a -3. So we're starting at -2, -3. We're starting way down here. And we have to remember that a square root function can only go in one direction because of imaginary numbers. So when we figure out which direction we want to go in, we can either have the square root function going this way to the right or this way to the left, but it can't go both ways. So what I mean by that is on my table, I'm either going to be able to use -3, -4, -5, or I can use -1, 0, 1. I can't use both sides. Okay? And I'm going to show you what that means over here. So on my table, I'm going to check. I'm going to put -2 here, in the middle, and I'm only going to check the two numbers around it, like directly around it. So I know -2 gives me a -3. I know that ordered pair. Okay? But I want to see the other ordered pairs, because only one of those two are actually going to be able to give me a number I can use. So if I plug in the radical, this -3, what is -3 plus 2? We get -1. And here's the issue I want you to look at. What is the square root of a -1? And I'm hoping you recognize real quick it's going to be an imaginary number. We can't have a square root of a negative number, because the square root means what number times itself gives me what's inside. Well, nothing times itself gives me a negative number, because two negatives make a positive. So I can't go this route. This is the side that I can't use, which means the only numbers I can use will go the other way. By that I mean, if I plug in a -1, I'll get a positive number under the radical. As -1 plus 2 is 1. And I know the square root of 1 is just 1. And then 1 minus 3 will give me a -2. So I get an order pair here. So over here I get the order pair -1, -2. And then from there, I got to figure out what other numbers on this side I can plug in, because again the square root is very picky. So like for example, I can't plug in 0, because if I plug in 0, 0 plus 2 is 2, and so you have the square root of 2 minus 3. But without a calculator, do you know what the square root of 2 is? No, even with the calculator it's going to be an ugly decimal. We don't want to plot decimals, so I don't want to use that number. So I can't use 0. If I plug in 1, I'm going to get 2 plus 1, which is going to be 3, but I don't know what the square root of 3 is either. But if I plug in 2, I want to plug in 2 because if I plug in 2, inside that radical I get a 4. And I know what the square root of 4 is. The square root of 4 is 2. Then I have 2 minus 3 and I get a -1. So there I get a pretty ordered pair of 2, -1, and you can see the shape of this graph finally looks like that. Okay, so we'll stop this video here. It's getting a little bit long, and we'll pick up with another one.